Hello everyone. So for one of my future project, I need to program some NFC tag using an MFRC522. The main problem I encountered is that the MFRC522 is mainly used for RFID tags. And of course, NFC and RFID are not the same thing, otherwise they would be named the same things. But if we do a little bit of research, we can see that NFC and RFID are essentially the same thing, of course, with some little bit of difference. But to get a better grasp of how it works, and for my own understanding before starting my own project, I wanted to do a little example that everyone can download. The link will be down in the description. So I made a little example, an interactive example, so that to once again have for myself a better understanding of how it all works. So for my own setup, what I have right now is basically an MFRC522 module. I purchased some Ntag213 on Amazon, but the example that we will see works for 213 and 216. It's essentially the same thing. The main difference between the three different tags is the address space that is available to you. And for example, for the example, I'm using an Arduino Uno, but I've also tested it with an Arduino Micro. It works exactly the same. Take whatever Arduino you have laying around in your room, and the example demo program should work the same. The example program will allow you to check if everything is good, if everything is working, if your wiring is good, if the module is not broken, if the NFC tag is good, and so on and so on. You will be able to read whatever data is written inside the NFC tag, sorry, as of right now, and also you will be able to write whatever you want inside the NFC tag. So before we go right inside the program, I want to show you just a little bit of how the addresses and how the memory space works inside an NFC tag. So inside an NFC tag, we have some addresses. So this is an example for NFC tag 215. You can see that the NFC tag itself have 135 different addresses, and each addresses have 4 different bytes. So let's say I want to get the first part of the serial number of the NFC tag. I will call the address 0, and it will return the 4 different bytes, the first part of the serial number. And let's say I want to read or write to change the password. So I will call address 133, and it will return. If I do a read, it will read whatever is inside the password memory space, or I can do a write to write a new password instead of the one that is currently inside the NFC chip. So enough with how the memory space work. Let's go right into the program. Let me clear all of that. And this is the program itself. So if you just want to go and test your module, you don't have to look at the program. You just have to download it and load it inside. As it's written right here, you just have to plug your Arduino, wire everything so that the MFRC module is actually plugged to your Arduino, and the Arduino is plugged to your computer, and just upload this program to your Arduino, launch the serial monitor, and you should be good to go. So I've actually just did that. Let me press the reset button on my Arduino, and when the Arduino starts, you will be prompted with that on the serial monitor. So let me, alright, there we go. Here are the 4 different actions that you can do with this program. You can test if everything is good. You can read whatever memory spaces that you want, or you can write whatever you want to the NFC tag. You can also do exclamation mark home to get back here, so you will once again see all the different actions that you can do. So first of all, let's say I just plugged my Arduino, I did the wiring, and before I want to read any address space, or before I want to write any address spaces, I want to check if everything is working correctly. So what I will do is just do an exclamation mark test, and it will suggest me to put a tag near the module. So I put this part is actually taken from the example, but it's a little bit arranged for the use case. So I will take my my tag, put it on the MFRC module, and you will see that it's working correctly because it's reading the tag over and over and over again. It will, let me remove the tag, it will give you two information. Well, the first information is obviously that the tag has been detected, and it will give you back the UID of the tag itself. So the UID is, it actually is the serial number of the tag. So let's say I want to scan another tag. Alright, let me grab another tag. There we go. So once again, it tells me that it's detected. And if I scroll a little bit up, we should see, oh, I think I went too far up. There we go, somewhere around there. You can see that it actually changed, that the UID is actually different. So now I tested two different tags. I know that the MFRC module is working, is actually communicating with the Arduino because it gave me something back. And I know that I can detect two different tags. So I know that my wiring is good, that the tags are good, that the module is working correctly, that my Arduino doesn't flinch or whatever. So I can do something else. Let me go back to the home page. So exclamation mark home. And this time I want to read whatever is inside the NFC tag. So I will do exclamation mark read. And here it will tell me that it will ask me which page I want to read. So whenever I'm inside a section, I can do an exclamation mark help, and it will tell me what is actually waiting here. So the read function will actually allow you to read 4 pages at the same time. So once again, when I explained before, 1 page is 4 bytes. And like I said before, the main difference between Ntag213, 215, and 216, I did a little mistake here, it's 216, is that the memory space that is available to you. So you can see that the 213 has a smaller memory space than the 216. 213 is smaller, and the 215 is actually in between all of the two. All right. So let's say I want to read the page 4. So if I go back just to the little chart here, you can see that page 4 is actually the first spaces that is available to you, the user. The read function will actually read 4 pages at the same time, so we will get the result for page 4, page 5, page 6, and page 7 at the very same time. So, alright, let's say I want to read page 4. I put page 4. As of right now, I didn't put my tag on the module. If I wait a little bit, sometime it will tell me that it didn't detect any tag again. So I will take my tag, I will put it onto the module, and now it blurts out, okay, so here is the content of page 4, here is the content of page 5, page 6, and page 7. You will see that the values are written in hexadecimal. This is just for ease of use, so that you can interpret more easily 1 byte by 1 byte. And let's say I want to check another page, let's say page 5, just the following page. I actually left the tag onto the module, so it didn't tell me, well, it told me that it was waiting for a tag, but it detected it right away, and it brought out the content of page 5 right after it. And let's say I want to read page, let's say 55, it tells me, okay, I didn't write anything onto page 55, so page 55 and so on, so it actually tells me that page 55 is actually empty. But let's say I want to write something into page 55, and that will be a good example because I didn't prepare anything, so you will see that it is actually not stage. Let's say I want to write A, B, C, D, E, F, G. So if I bring up the ASCII table, A, B, C, G, F, G, we should get 41, 42, and so on, up to where I will stop. So I can either go do a /home, or I can directly go to exclamation mark right. Once again, it will ask me which page I want to write. Let's say I don't know what is the right function, so I will do exclamation mark help. And it tells me that the right function allows you to write any number of pages at the same time. So not like the read function that is always reading 4 pages at the same time. The write function on my program, this is a little bit different in reality, but the write function on my program is able to write only 1 page, 2 pages, or 15 pages if you want. It tells you that 1 character equals 1 byte, and that you cannot, this is the most important part, that you cannot write to page 0 to page 3. Why? Because page 0 to page 3, let me grab it back just for you. Page 0 to page 3 is actually used for the system of the NFC tag itself. So let's say I want to, we said we want to write to page 55. So let's say I want to write page 55. What is my message? So I said I want to write A, B, C, D, E, F, G, H, L, for example, and let's stop to L. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, it's not divisible by 4, so we'll be able to see some differences. Alright. And now, it told me that my message was ABCDFG and so on and so on. It was 9 byte long, and it will write up to 3 pages, which is, yeah, of course, because 9 bytes is not divisible by 4, evenly divisible by 4. And it will be written at starting at page 55, which is actually what I demanded. Of course, it was waiting for a tag, but because I left the tag on the module, well, it immediately detected it. And once it had finished reading everything, it told me that the message has been written. So now, if I go back to the read function, I can actually call page 55, and we can see that there is 41, 42, 43, 44, 45, and so on and so on. Remember that this is actually hexadecimal. So if I go back here, we'll see that we have 54. I'm actually, what did I write? HL. Oh, okay, so I missed a whole bunch of the alphabet. So sorry, I don't know my alphabet. But actually, this is a good. This was a good test to see if everything works and everything works correctly. All right, so that's it for the main interface. Once again, this example will be available down there in the description, and I will also link to the GitHub. I've never actually used the GitHub, so if there is something wrong with the GitHub, just let me know. And don't hesitate to come back to me if you encountered any problem with the program itself, with the example. And that's it. Thank you for your attention. Bye.